So now in this video we come back to the circuit I did in the last video. We're comparing the voltage from the light dependent resistor voltage divider with a fixed resistor voltage divider. Right now our signal from the light dependent resistor voltage divider is lower. That's why the blue LED is lit up right now. So I could turn the overhead lamp on or use my headlamp to turn the light on, but we're going to cause a problem. So I'm using a flashlight right now, and I did an earlier video much like this one, and you can see the voltage is going up and down really fast. That's because the flashlight is the LED is turning on really fast and off, and so both LEDs were lit up because the output was going high and low rapidly as the voltage goes above and below the reference point. So of course that's not very useful for much. So we're going to smooth that out, and I did this in a recent video. I'm using the same capacitance, and we just put a capacitor there in series with the low side fixed value resistor, and this is the exact same light. There you can see we have a smooth voltage. When we get enough light on there now, the voltage stays up instead of going up and down rapidly, and the output stays high. The red LED stays lit. And I did make a schematic for this video, but it's almost the exact same as the last video, so I'm not going to go over the details too much. Just the main thing is I just grabbed a 47 microfarad capacitor and saw that it worked pretty well. It is parallel to the fixed value resistor. As the light keeps hitting and stopping on the light dependent resistor, the voltage is bouncing up and down without the capacitor there, and so the input sees that voltage. No current goes in or out. And by the way, this is the non-inverting input. It's higher than the inverting on the schematic, but on the physical component, the non-inverting, the plus, is below the inverting, the minus. Just want to make sure I point that out. So in any case, the light dependent resistor, when a bright light falls on it, it will charge up the capacitor. The resistor here will prevent it from getting a higher voltage than you would have got otherwise. But in any case, when it gets darker, it doesn't conduct near as well, and so the capacitor starts discharging through the resistor. But if it's going fast enough, it's going to hold the voltage really steady, as we saw there before. So 47 microfarad right there. That's the negative side. Gray band, you got to make sure you insert it in the right way. Going to the negative rail, which means the positive side will go over there, which has a more positive voltage than ground. And quickly before we wrap this up, I also want to mention there's Schmitt trigger circuitry, which accomplishes a lot of what we did in this video, but I don't think it would have been effective enough. But in any case, the output, it is fed back to the non-inverting input through a resistor. So you get some of the output voltage back to the reference voltage to help it stay above or below the reference voltage, even if it's trying to waver a little bit. But I don't think that would have been near effective enough in this video. As we saw, the voltage was bouncing all over the place. So it looks like that smoothing capacitor did a good job all by itself.